Whether you believe in mysterious time travelers or not, I urge you to watch this story until the end. Because what I'm about to tell you is not science fiction. It's a real experiment, and its results could shatter everything you think you know about reality. 1. A strange beginning. It all started back in 1946. Soviet physicist Nikolai Kozyrev was researching something called the brain field theory. In truth, a study of the unique energy field produced by the spin of celestial bodies. While observing a distant star, he noticed something bizarre. After calculating where the star would be in the future, he aimed his instruments at that point in space. And to his astonishment, he could still detect the star's energy field there. It was as if the star's future had already left a signal in the present. 2. Time is not what you think. This led Kozyrev to a shocking hypothesis. Time isn't just the ticking of a clock, it's a real, physical energy. It has density and speed. It can accelerate, slow down, even run backwards. In his view, the past, present, and future are not separate stages. They coexist in a vast time web, and we're simply moving along one of its countless paths, mistaking it for a one-way road. 3. The first-time distortion. After years of calculations and experiments, Kozyrev built a device using a concave lens that could bend light, and with it, distort time by up to 10 seconds on a microscopic scale. But he wanted more. Using a massive concave aluminum mirror, capable of reflecting electromagnetic energy, he aimed to bounce time energy back into itself, placing a person at multiple points in the space-time continuum at once. Just as he was on the brink of success, Kozyrev died suddenly under mysterious circumstances. 4. The forbidden continuation. In 1990, in a research facility on Dixon Island, deep within the Arctic Circle, 3 scientists, Kaznikov, Sayev, and Trofimov, took over the project. On the very first day, things went wrong. Test subjects entering the device reported a deep, irrational fear, as if they were being silently watched. Above the lab, disc-shaped glowing objects appeared in the sky. Inside the device, subjects saw flashing symbols. Symbols that, when analyzed, were found to match those of ancient civilizations, with the largest share belonging to the Sumerians, the oldest known human culture. The team speculated. The participants had accidentally tapped into time-stored cultural memories. 5. A meeting across time. As experiments continued, subjects grew more comfortable, the fear fading into an unnatural calm. One reported feeling weightless, then saw his surroundings twist and blur, until suddenly he was in a sunlit park in the afternoon. Children were playing. One boy's face struck him with shock. It was himself at the age of 5. The moment their eyes met, the scene shattered, and he was back in the lab. 6. The mirror's revelation. Records showed 32% saw scenes from their own past. 68% saw historical events or even visions of the future. Many believed they had truly traveled through time, and some claimed contact with life forms from other dimensions. Around 1/3 encountered a being made entirely of light. It watched them in silence. They couldn't see its face, but it was not human. This brought to mind the zoo hypothesis, the idea that advanced alien civilizations have already discovered Earth, but choose to merely observe us, as if our planet were nothing more than a cosmic wildlife preserve. 7. Secrecy and disappearance. UFO sightings around the lab increased. After just 1 year, the Kozyrev mirror experiments were abruptly shut down, classified as top state secrets, and all data vanished from public record. Mainstream science dismissed Kozyrev's time theory as absurd. Yet many of his once ridiculed ideas were later proven correct, including his prediction of volcanic activity on the moon. 8. The unanswered questions. Was the Kozyrev mirror truly a time machine? Were the visions hallucinations or glimpses of a deeper reality? And who, or what, were those beings of light? We may never know. But one thing is certain. This experiment happened, and its echoes may still be rippling through the fabric of time, waiting for the next brave soul to step inside. Why astronomers believe humanity will never reach the edge of the universe. Once you see this, you'll understand just how small we really are in the cosmos. What you're looking at now is the view from the ground, gazing up at the sky. In our daily perception, Earth is unimaginably vast, so vast that the land beneath our feet seems endlessly flat. We can't even feel that we're standing on a sphere. But when the camera is lifted into low Earth orbit, astronauts capture images of our planet, and the horizon begins to curve ever so slightly. Those flat Earth myths are shattered instantly. A little farther out, at 29,000 kilometers from Earth, a photograph reveals our planet in its entirety for the first time. The blue oceans, the white swirling clouds, suspended in the blackness of space. This is the Earth most of us remember from pictures. From the Moon, 380,000 kilometers away, Apollo astronauts looked back to see our home as a small blue and white marble, floating alone in an endless void. Familiar, yet strangely alien. Once we break free from Earth's gravity, our perspective shifts to the scale of the solar system, and Earth begins to shrink rapidly. From Mars, 160 million kilometers away, the Curiosity rover captured an image in which Earth is reduced to a faint white speck. Farther still, 1.4 billion kilometers away, beneath Saturn's rings, the Cassini spacecraft looked back. The Earth was so small that without a label, you might not believe it was there at all. And then there is the legendary pale blue dot, taken from 6.4 billion kilometers away by Voyager 1. In the image, Earth occupies just 0.12 pixels, a speck of dust caught in a ray of sunlight. Our smallness is no longer poetic, it's measurable. Right now, Voyager 1, humanity's farthest emissary, has been traveling for 47 years and is 25 billion kilometers from Earth. Even at the speed of light, it would take nearly one full day to reach it. But the true gravitational boundary of the solar system, the Oort cloud, extends 2 light-years away. At Voyager's speed of 17 kilometers per second, it would take 300 years to reach the edge and 30,000 years to pass through it. Beyond that lies the Milky Way, 100,000 light-years across, home to at least 200 billion stars. Our galaxy belongs to the local group. Over 50 galaxies spanning 10 million light-years. Even larger is the Virgo supercluster, over 110 million light-years in diameter, containing hundreds of galaxy groups. And that itself is part of the Laniakea supercluster, a staggering 520 million light-years across, containing at least 100,000 galaxies. At this scale, the universe is no longer a smooth scatter of galaxies, but a vast cosmic web, filaments spanning billions of light-years, woven together by dark matter and dark energy. The superclusters form the nodes of this structure, separated by cosmic voids tens of millions to billions of light-years wide. Scientists estimate the actual universe could be at least 250 times larger than the observable universe. With today's technology, even leaving the solar system is nearly impossible. Faster-than-light interstellar travel remains science fiction. This is why astronomers believe that, for as long as humanity exists, we may never reach the edge of the universe. It's not pessimism. It's a sober reminder of the vastness we live within. And perhaps, the very reason exploration matters even more. Can light ever reach the edge of the universe? Imagine this, a clear, star-studded night. You look up, pick up an ordinary flashlight, and shine it into the endless sky. A beam of light cuts through the darkness for just 1 second, then you turn it off. Now, the question arises, will that beam of light ever reach the edge of the universe? According to Einstein's photon theory, light isn't continuous. It's made of tiny particles called photons, each carrying energy. Once released, photons travel like bullets through space. Their energy doesn't just disappear. So even after you turn off the flashlight, the light already emitted continues moving along its path until fate intervenes. The first obstacle, Earth's atmosphere. Packed with molecules, dust, and tiny particles, it acts like an invisible net, absorbing part of the light. If a fraction of the beam survives and escapes into the true vastness of deep space, it still isn't safe. The cosmos is full of interstellar dust, wandering asteroids, planets, and stars. And the most deadly, black holes, where gravity is so strong that not even light can escape. Once trapped, a photon is gone forever. Even if the beam is extremely lucky and avoids all obstacles, can it reach the edge of the universe? The answer is still no, because the universe is doing something counterintuitive. It is expanding, and at a speed faster than light itself. Back in 1929, American astronomer Edwin Hubble used the most advanced telescopes of his time to study distant starlight. He discovered something astonishing. Nearly all galaxies are moving away from us, and the farther they are, the faster they recede. Some appear to move faster than light. At first glance, this seems to violate Einstein's relativity, which states that the speed of light in a vacuum is constant, 300,000 kilometers per second, and no object with mass can exceed it. Even if you chase a beam of light in a near-light-speed spaceship, from the photon's perspective, you are still standing still, and it moves away at the same absolute speed. So how can galaxies move faster than light? Hubble's answer: they aren't moving at all. It is space itself that is stretching. Imagine dots on a rubber sheet that is being stretched. The dots themselves don't move, but the distance between them increases. This is the essence of cosmic expansion, the harsh reality. Light from extremely distant galaxies can never reach Earth within a human lifetime, because the space through which it travels is expanding faster than it can cover. Even if humans could travel at light speed, the ever-expanding universe would push the edge farther away, making it unreachable forever. Thus, everything in the universe, stars, planets, galaxies, even ourselves, is trapped within this cosmic expansion. And beyond this invisible barrier, what exists there? Another universe? A void? A higher dimensional world beyond our comprehension? Perhaps the answer lies forever beyond that 1-second beam of light, eternally out of reach. If you're fascinated by the mysteries of the universe, don't forget to like and subscribe. See you in the next video.